Hello friends, welcome to a new video. Today we will cover counter type ADC. In the previous video we have covered converter basics, so if you have not seen, you can go and check it out. So come to the point, counter type ADC. This ADC means analog to digital converter. Counter type ADC, it converts the analog signal into digital signals. So let's see some features of counter type ADC. It uses a counter. Obviously counter counts the digital signals. Counter type ADC is a direct type ADC. In the previous video we told what is direct type ADC and what is indirect type ADC. Direct type ADC means this will use its internal components to convert all the analog signals into digital signals. Counter type ADC is a direct type ADC. It uses a counter to do all the process. We will check the block diagram and working principle of counter type ADC. In counter type ADC, the output of counter is fed to a DAC and counter increments its count. It means it uses a digital to analog converter. Then the DAC will go to a next block diagram which is called comparator. Counter type ADC is also called as staircase approximation ADC or RAM type ADC. If we see the analog input of counter type ADC, we can see that it is a form of staircase just like this, and this section will increment it in this portion just like a staircase, so that it is called as staircase approximation type ADC or RAM type ADC. If we see the waveform of digital output, then it will just like this, just a form of ramp, so that it is also called as RAM type ADC. These two names are important for short question. We have already said it is a direct type ADC. So let's check the block diagram of counter type ADC. This is the general block diagram of counter type ADC. We will discuss the working of all the blocks. We will start from control logic block. It is the main component block of counter type ADC. So let's discuss its working. So control logic will reset the counter in every section. Then it also instruct the clock signal generator to produce clock pulses to the counter. Then comes to the second block, counter. The value of counter gets incremented by 1 for every clock pulse, and its value will be in binary format, means 0 and 1. It gets the clock pulse from clock signal generator, so it is also very important part. The output of counter is directly fed back to the DAC, means digital to analog converter. Here you can see that the counter produce digital output which is also connected in the screen just like a tapping, and the digital output is also feedback shown in the display is feedback in the DAC, and this DAC receives the digital form of output from the counter, and this DAC will convert all those digital signals into analog signal, and this is known as VA. This VA is the output of DAC converter, and it is fed back to the comparator in the inverting terminal. This minus sign means it is the inverting terminal of the comparator, and you can check that this plus sign means non-inverting terminal, and it gets VI. It means that external analog input. Comparator compares between these two signal VI and VA. VI means external analog signal and VA means the output of DAC. The output of the comparator will be 1 when VI is greater than VA. It means VI is greater than VA. It will produce 1. When it produces 1, this comparator will give the signal to control logic, and control logic will begin all the work just like previous. When it will reset the counter and instruct the clock pulse generator, then counter will produce digital output and it is fed back to DAC, and DAC produce VA and it is fed feedback to the inverting terminal of the comparator. In the second case, the output of comparator will be 0 when Vi means external analog supply equal to or less than Va. It means output of DAC is greater than the external analog output, then it will produce 0, and when comparator produce 0, it will instruct the control logic to stop the working, and the output, the digital output of counter is shown to the display. This is the digital output which is taken as the output of the main section when the comparator produce 0. I hope you have understood the working of counter type DAC. It is related to every block. If you understand all the blocks working, then you can easily explain after seeing the block diagram. So just a recall, first option is control logic. It will instruct the counter. Counter gets clock pulse from clock signal generator. Counter produce digital output which is also shown in display, and it is feedback in DAC. DAC will produce VA and comparator will compare Vi and Va. Comparator will produce 1 when Vi is greater than Va and instruct the control logic to start the operation again. And comparator will produce 0 when Vi is less than or equal to Va. It will instruct the control logic to stop the working, and digital output of counter is shown as output in the display. This will be the main output. Now check the waveform of counter type ADC. Now you can see this is the analog input and this is the digital output waveform of counter type ADC. This is the staircase. I have already told you why it is called a staircase, because the analog input is increased as the shape of stair, and it is a sawtooth signal. When it comes to the digital output, it is just like a ramp shape, just like you can see that is a ramp shape, so that it is called as a ramp type counter. I hope you have understood the working and the waveform of counter type ADC, and please like, share and subscribe. And if you have any question, you can ask me in comment section.